Okay, it's working here. No. Yes, 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 yes. Hold on, hold on, hold on, hold on, hold on, hold on. Just wait for a minute. Okay, I'm seeing it. Yeah. System of particle is working on the YouTube. So now you can see there also. I'll send you the link afterwards. Okay. Or if you want to see, I can share it now also if you want. I can share the link now also. Anna, copy the link. Copy the link. Copy the link. Copy the link. Cut. So students, we are going to start now this chapter that is system of particles. Let me show you on the WhatsApp what is happening. Let us see.
கொஞ்சம் பேர் தான் இருக்குது.
Just 1 second, students. I'm giving some descriptions on the WhatsApp group here. Okay, where was the initial? Yeah, this is our. So if you see here, just hold on. It's live here. Share. WhatsApp. Okay.
பதிமூணு பேர் தான் இருக்குது. என்ன பண்றாங்க தெரியல.
Don't make noise. Don't make noise. Let me unmute now. I have only one mic here. Okay. Yeah. Okay. So take your pen and paper, and whatever the doubts you are having, you can ask side by side. I'm starting this chapter. Okay. So let us start with this. Yes. So the name of the chapter is what? As you can see, it is what? System of particles and rotation, motion. Name of the chapter is what? System of particles and rotational motion. Okay. So we'll start from the basic. I'll remove this. Who is the person is? Don't make noise. Yeah. So you can see here, it's on your screen already. Okay. White pen. So we are going to study now this chapter that is system of particles and rotational motion. I hope there is no doubt in this. Let us proceed. So what we are going to do is this in this chapter. We'll also include the concept of center of mass. See, this will be not proper rotational mechanics. I mean, this will be proper, but before rotational motion, there is one more chapter which is named this. So let us start with this. You can see here what is happening. This is what? This is big stone. What has happened now? Is this meeting working? I'm hanged here. I don't know, I'm hanged here.
The screen is not visible properly.
No, now it will be visible.
Your voice also, sir.
Yeah, I hope it's audible now.
Yes,
You can reply in
sir.
the chat. Yeah, okay. So I'm sharing the screen there back again. So you people want the proper rotation or just hold on them? Let us see the proper rotation. Hold on. I'll just start with the rotation mechanics then. Just hold. Let me use that PPT. Rotational kinematics. Let us just see the rotational kinematics. Okay. No issues. Just hold. Just one more minute. Okay. So by the way, little bit information I'll give of this. You can see that this stone is balanced by at this point. This what is happening? That this stone is okay. It's balanced at this point. You can see this thing. So what's the factor which is allowing this stone to balance? Okay, there is some point which is known as center of mass. You might have read about center of gravity also. So in some cases, center of mass and the center of gravity are the same points. In some cases, the center of mass and the center of gravity are different points. Okay. But this is not topic. Our topic is what? What is our topic? After our topic is rotational mechanics. So we'll see that only. I have PPT for you now. I'm launching that PPT. Let me remove these PPTs which are not for our use now. Okay. So yeah. It is opening. Just hold on. It is opening. So we'll directly see rotational mechanics only. Okay. Initially, I've known the PPT from basic center of mass and all these things. Now we'll just see rotational mechanics. So it's working. Yeah. Rotational mechanics. Yeah. Enable editing, and that will work. Hold on. Let us see from the first. Yes. Hold on. If some software is interfering in between, just wait on. Now it is fine. So let us start as per your demand, rotational kinematics, okay, or rotational mechanics. So students, as per your demand, let us see this chapter. This is rotational kinematics. Somewhere you will find this chapter. Now you can make the notes, proper notes, okay. We'll just see specifically, individually we'll see which chapter, that is rotational mechanics. So this is rotational mechanics. Rotational mechanics. Somewhere you will find this chapter written as rotational kinematics. Why? Because we have seen in kinematics that what happens basically, a car is moving, a body is moving, and all these things happen, but they are all linear. In rotational kinematics means what? Motions will be same, equation will be same, but some symbols will be changed, the scenario will be changed, everything will be circular kind of, rotatory kind of. Okay, I hope it's clear. Everything will be what? Like rotatory kind of. Okay, I hope this thing is clear. Let us see now. So what we are going to study in this chapter, which is specifically rotational mechanics. This chapter, Raksha, is, as per your demand, it is rotational mechanics.
Yes, sir.
This is rotational mechanics. No need to speak in the session, okay? You can speak, but there is a lot of noise today. So no need to speak. You can put a text in the chat box, okay? Because only one mic is allowed, that is mine. So this is learning objectives. First, we'll see motion of a rigid body. Okay, for what we are going to see, at first we'll see the motion of rigid body. For this, we'll try to understand that what is basically rigid body. कि basically rigid body क्या होता है? What is rigid body? Then we'll understand its motion. So this completes the topic, motion of rigid body. First, you can note it down if you want. Okay. Then we'll see the angular velocity and its relation with the linear velocity. You all know this thing. Suppose you are having a track like this. Dum, 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 dum. This is what? Horizontal track. Suppose a car is on this track. Okay, if it's moving with some velocity, say v, and suppose this car is not having any acceleration a. Acceleration a matlab kya? change in speed per second. Speed may be increasing or decreasing. If it's decreasing, this is what? Deceleration. Okay. Suppose this car is having speed or velocity in x cap, which is constant here. So suppose at some turning point, this car makes a very dynamic, instantaneous turn. Okay. So there will be some quantity which is associated with this car at that point, which is known as omega or angular velocity of the car. So what is the relation between the linear velocity at this turning point, circular kind of, circular arc is what? Arc is a part of the circle. What is the relation between angular velocity at this point and what is the relation between this linear velocity among this? We'll study in this. Third, the question which you were asking, Raksha, that is torque. Okay, we'll understand. Fourth, we'll see how a rigid body remains in equilibrium. Equilibrium means what? Till now, we have studied this thing as per the kinematics. As per the kinematics, we have studied this thing. That is kinematics matlab kya? 1D motion or 2D motion. 2D matlab XY plane, YZ or ZX. That for these kind of kinematics or motion, 1D motion, 2D में क्या होता था? The word equilibrium, the word equilibrium का मतलब क्या होता था? What is the meaning of equilibrium word? Equilibrium का मतलब होता था that F net is equals to 0. But once if we have reached up to this point, that is the third topic, when we have cleared our third topic, that is torque. So now you will say the equilibrium in rotational kinematics means what? The equilibrium word in the rotational mechanics means not just F net equals to 0. F net to 0 hona hi chahiye. With this, one more thing is important. That is what? Torque net is equals to 0. This you know. What is F net equals to 0? For torque net to be 0, what is this torque? And how to put this torque, net torque on a body as 0? That we'll understand after the third topic. Okay? At fifth, we'll see rotational kinematics about a fixed axis. Let's suppose you can see this. This is what? Some specs. Okay. It is moving like this. Anna, if I move this specs like this, somewhat. Okay, so what's going to happen? What's going to happen? If I'm moving this like this is rotating about a fixed axis. Anna? So that will understand in the fifth, after completion of the fifth topic. I hope it's clear. Let us move next. So motion of a rigid body, first topic. Our first topic, that is motion of a rigid body. Okay, very good student. Excellent. Redmi and Raksha. So as you can see on your screen, what is this happening? See, it is said like this. First of all, we understand what is rigid body. So they say like this, rigid body is a solid body in which the distance between any two given points of a body remains constant in time. Suppose let us consider the fan. In this fan, let me mark these 2 points, white color. And the distance between these points, let me mark it as small l. We know this thing. We know this thing that if this fan is moving like this in a circular manner, if this fan is rotating down, what's going to happen? Always and always, irrespective of what, that if you change the speed of the fan, the distance between these 2 points will always remain constant. That is L. So that's why we consider this Bajaj fan as what? A rigid body. Even this definition is not valid with, as an example for this fan only, this is also valid for the pen also. You can see here, if I mark some point on this pen, let me mark this with red color. So this point and this point, these 2 points are at distance L on this pen. Suppose if I throw this pen on your face, or if you throw this pen on my face like this down, so this will rotate like this and do translation also, and it will reach you. So irrespective of its rotation plus translation, moving like this, always and always, ये जो 2 point होंगे इनके बीच में, in between these 2 points, the distance will always be constant. That's why we consider pen as also what? A rigid body. So I hope the rigid body definition is clear. Please reply in the chat box. Please Redmi and Raksha, please reply in the chat box fast. Anybody can join. The session is going to be interesting. So you can reply in the chat box, students. Is it fine? Did you understood this motion of, I mean, just a rigid body, first of all? कि rigid body क्या होता है? Very good, excellent. Yeah. Very good, okay, very good. Cool. ठीक है? Now let us see next. Okay, let me ask you from a question from you, okay? In which situation, so there is a question for you that among these two situations, in the first situation, if we see, there are two blocks and in between these two blocks, the spring is present, which is in what position? Can you say? It is like compressed. Okay. So they say in the situation spring block system can be treated as, इसमें से कौन सा spring block system will be treated as a rigid body? What do you say? इसमें देखो spring is present like this. I will not comment whether it's natural length, it's compressed. See, this will not, you will not consider it as a natural length. This you can call it as a compressed little bit. Okay, no issues, it will work. Okay. And this is also the spring which is extended. But the difference between both of the system is this. इन दोनों ब्लॉक का स्पीड विद डायरेक्शन दैट इज वेलोसिटी इज सेम. इन दोनों ब्लॉक का स्पीड विद डायरेक्शन दैट इज वेलोसिटी इज सेम throughout the motion, keeping the spring intact, in keeping the spring between them as in what? In a film position, not allowing the spring to get dropped. But here you can see where the spring end is connected to this block, it is moving with this v2 speed which is greater than v1. So the spring will 100% extend. So what you will comment after observing both of the situations, first and second, that in which the spring block system can be treated as a rigid body? Answer. Your time starts now. What I've explained you, the distance remains constant. If the distance remains constant, see, we have seen the fan situation. If this distance remains constant, yani if this is also moving with some speed, this will also be moving with the same speed. Perfectly, if I say both of the points will be moving with the same velocity. Okay. First system, you say first system, excellent. So answer is this, students. Answer is what you can see on your screens. Answer is figure 1. What's the reason? Because both of these blocks which are moving with the v speed are keeping the block, are keeping the spring in between them in a stable position. So they're moving like this. So you can comment like this, all the points which are here, you can take anywhere, here also, anywhere. But I will comment here, this point and these points is always having a distance L between them as constant, even this complete body is moving like this. Like in this case, if initially the block was here, distance was L, now the distance is L dash, which is increased. Okay. So this is a change here. I hope the change is clear. Let us move next. Let me see how many students have joined. Okay, you are only present. Good. So let us see the various motions of the rigid body. What are the various motions of the rigid body? If you comment. Translation motion. Okay, this is also motion of the rigid body. Let us see it properly. So you can see here, block slides. What is happening? If the block is sliding, what is happening?
Sir, in both the particles, velocity is same.
Yeah, in both of these particles, if you see, the velocity is what? Velocity is same. That is, this is v1 and this is what? This is v2. See, don't get confused in this. Let me tell you something. Let me raise this. Understand this thing. If you observe from here, for marking the difference in the point, that this is what? P1 point, this is P2 point. Okay. Don't get confused with the subscript. This is V1, this is V2. Okay. V1 is the velocity vector for the P1 point. V2 is the velocity vector for the P2 point. But here what is happening is this. Both of these velocities are same. V1 is equals to V2 here. Okay. Understand this. V1 is equals to what? V1 is equals to V2. So this is pure translatory motion. Okay, all the particles of the body are moving together. They have same velocity. Not just this. It is not just about the P1 and the P2 point. It is about all the points, P3, P4, P5. For all the points, the velocity vectors will be same. V1 equals to V2. So this is pure translational motion. Okay, now let us see about the next. So various type of motion rigid body shows. Rigid body, you know this thing, that if distance between the 2 points remains constant, irrespective of the motion of the body, such a body is known as rigid body. So such a rigid body shows two kind of motions. Pure translational motion, which we have already seen now. Now we'll understand the pure rotational motion. Okay, what is this? Let us see the video. So if we fix rigid body about an axis, like a fan, such that the axis is fixed and the body rotates about the axis, such a motion is rotational motion, and such is what? Rigid body is a fan, and it is showing pure rotational motion. So if I on this video, you can see here what is happening. So fan will be moving now. I switched on. Now you can
So
see.
is torque and rotational motion both are same?
See, I'll explain you. Just hold, just watch here carefully. Okay, I'll clear your doubt. No issues. Okay, just wait. So you can see I have marked a black color marker here. So the point, you know, how it's moving, it's rotational. Okay, not just this point, all the points on the fan, this are moving in the same different peripheries. Okay, so now your question is this. So there is one more before I clear your doubt. Okay, there is one more type of motion which is shown by the rigid body, which is known as T plus R. What is this motion T plus R? T plus R motion means translation plus rotation, which gives rise to a new kind of motion, which is rolling motion. Rolling motion is what? Like a wheel rolling on what? Earth. Right? So if you see this, what is happening? In this motion, all the particles rotate about an axis of rotation. An axis of rotation moves with respect to the ground. This is happening in what? Rotation motion. Okay? So this kind of motion is known as rolling motion. So it is what formed of translation plus rotation. So rolling हो गया. देखो वापस देखो. It will show it again. Hold on. Rotation, pure rotation plus pure translation is equals to rotation plus translation. That is rolling. Okay? I hope this clear. I hope this thing is clear to you. So now your doubt was this, कि sir, torque and what? Torque and what?
Rotational force.
Okay. So your doubt is this, कि torque. Let me explain. Torque and rotational force. Torque and rotational force. Rotational force. This is what rotational. Torque and rotational force. Are these both things same? So let me explain you. Okay. See, you have studied in Newton laws of motion. We have studied this thing in Newton laws of motion. What is that? That is force is equals to mass times acceleration. Okay. This force in the Newton laws of motion is vectorial force. It can be in the I cap direction or X cap we can name. It can be in the J cap direction or Y cap we can name. It can be in the Z cap direction or K cap we can name. Okay? These are different directions. So it can be in between also I cap plus J cap, whatever. But this is known as what? This is basically in a linear sense, always in one direction. It can be I J cap, it can be somewhere in between the plane. So this force is basically linear force. Linear force produces what? Acceleration, which is linear. Okay? So you will understand in this rotational kinematics chapter, as we have seen the variables in the term in the linear motion, that is linear force, linear acceleration, linear speed, linear distance or displacement. Corresponding to all of these were in kinematics, but once the term rotational gets added as a pre-term in front of this kinematics, it becomes rotational mechanics, rotational kinematics. Okay. So isme the linear force gets changed to what? Like shifted into what? Replaced by what? Rotational force, which is known as torque. Now, what is torque? That we'll understand. So linear force gets changed into rotational force, which is known as torque. If we talk about the rotational, so जो काम force का linear motion में होता है, that is producing linear acceleration, वही काम, that work is the same done by this rotational force, which is known as torque, producing alpha, that is rotational acceleration. If this is producing speed, this will produce omega. If this is producing x, this will produce theta here. So these all which we are seeing here, torque, alpha angular acceleration, omega angular velocity, theta angular displacement, these are angular variables. And these are linear variables. Now we can say like this, torque and rotational force are both same thing. Torque and rotational force are both what? Same thing. Okay? So you can reply in the chat box. Okay? If there is audibility issues. So we'll say here, yeah, very good, very good. Very good. Okay. Chat box is best. So we'll say torque and rotational forces are both the same thing. So you have already understood the force. That suppose this is what? This is some material. Okay. If I'm applying a force F in this direction, this will move fast with acceleration in shoom. But what is the torque then? So torque I'll explain in the next slides. Okay. Okay, very good. So for understanding the torque, we need to understand what is this axis of rotation. So I'm removing these things, okay? To understand the torque, we need to understand that what is this axis of rotation? What is known as axis of rotation? So line or fixed axis about which the rigid body rotates is called its axis of rotation. Remember all.
Sir, then if we take I cap, J cap, and K cap, then origin is the axis of rotation.
No, not like this. Suppose if you open the door, suppose I'll show you. Just have wait. Have patience. So we'll see in the further slides when I'll introduce the torque thing. Okay, so then you'll be able to understand perfectly that what is the axis of rotation. Let us see that. Okay. Okay, let us see this example in which the wheel is rotating. You have seen this thing in the cycle workshop. What is happening? That inside the wheel, there is a point where the axis passes. And if we keep the wheel like this, and if we move the wheel like this, the wheel rotates about the axis of rotation. So this axis is known as axis of rotation. I hope this is clear. Okay? This is known as what? Axis of rotation. Is it clear? Reply in the chat box. Is this thing clear? Reply in the chat box. Okay, I'll give you one more example. Suppose the door is closed. So what do you do? How you open the door? You just put your hands on this handle. Okay, you unlock it, trigger it, and you just push the door towards yourself. So what is happening? Actually, the door doesn't comes out towards you. The door just moves like in a circular arc. It may be clockwise and anti-clockwise with respect to the frame. It depends. But one thing is true about this axis. This door rotates. So this axis is known as axis of rotation. I'll use the short form AOR in the further slides or the upcoming sessions. This is known as axis of rotation. Kavya also joined. Very good. Yeah, your name is changed. Good. Okay, cool. This is known as what? This is axis of rotation. Okay, I hope it's clear. Now we'll understand angular velocity and its relation with the linearness. Write this topic and reply in the chat box that if you want me to proceed for the next slide. Write this topic, angular velocity and its relation with the linear velocity. And text me so that I can proceed. Very good, students. Very, very excellent students. Very good. Okay, so let us move. Angular velocity and its relation with the linear velocity. Let us see this. Okay. See, this, suppose this color kind of different, it's like very irregular kind of structure. This is known as what? This is a rigid body. This is what? This is a rigid body. Suppose, students, if I somehow pass an axis inside out this irregular shaped, unsymmetric shaped rigid body, and if I try to rotate this rigid body, if some Superman tries to rotate this very big rigid body via this axis Z, okay, with a speed which is angular speed, which is known as omega, okay. So we'll find the relations, and suppose then I mark a point P here, which is at Ri distance perpendicular to what? Perpendicular to this axis of rotation, this P point I'm saying. And at any point when this body is rotating and when I'm observing this P point, suppose I do what? At any point, suppose I, take a snapshot. You know then how to do your annotation. Suppose at any point, if I take a snapshot, this point will be having some linear speed in this direction. Okay. And then if I need to find the relation between the omega and that Vi, so what is the relation? If someone asks from you, no issues. Okay. Okay. So we'll say what is the relation between this angular velocity and the linear velocity? That is basically omega and Vi. इसमें relation क्या होगा? What is the relation between omega and Vi? So we say like this. Let us observe. For a particle at a perpendicular distance r, a relation with this. Remember, V equals to omega or V equals to r omega. Write this in your notebooks. This will be V is equals to r omega. Okay. Let me see that. What is happening on the YouTube? What is happening there on the YouTube? None of you are there. I started at 33 minutes ago, no? Okay, it's fine. So if you've written this relation, reply in the chat box fast, okay? Now let us find for all those points which are on the axis of rotation, the velocities. Written very good. So for all those points which are on the axis of rotation, we'll say like this, the velocities. If r is 0, we'll say it will be 0, fine. So you reply in the chat box at what time you want the class to be ended, because it was just a doubt.
Sir, let's wind up after this, no, sir, after this topic, angular velocity.
Okay. So we'll say like this, if we consider that all the points on this axis, okay? So for all these points, omega will be what? 0 because Ri is 0. V will be 0, so omega will consider as 0. Okay. So you students can leave. I'll continue the class and end at my own time. Okay. Okay, you can see the video. Or we'll see in the next class. No issues. Okay, so I'm ending it. This is what V equals to omega R. This is a relation. And this whole. So no need of verification of this. We'll just see the formula for you. Okay. Yes. So just wait. So in the next, from the next classes, okay, students, so you can leave the class.